In the last section, we finished up with our Postgres deployment file and the associated cluster IP service as well. So that's pretty much it for the boring configuration files, at least the ones around the cluster IP service and deployments. We're still going to write out a couple of different config files, but they're going to be much different than the ones we put together so far, because they're going to serve dramatically different purposes than the services and deployments we've taken a look at. In this section in particular, we're going to start looking at what a Postgres PVC thing down here is. First beginning by getting a better understanding on why we need this PVC thing at all. So just so you know, PVC stands for Persistent Volume Claim. Now the word volume in here is the same type of volume that we had worked back with in the world of Docker and Docker Compose a while ago. You might recall that we had previously made use of volumes in order to share the file system of a host operating system or a host machine with the file system inside of a container. And so we had previously used it with Docker Compose when we were working on that Create React app. We had wanted to make sure that every time we changed the source code of our project on our local machine, it somehow updated the files inside of the container as well. Now, to give you a good idea of what a persistent volume claim is, I first want to do a very quick review on what a volume is and why we need a volume at all with Postgres in particular. Because if we just start talking about what a volume claim is without really understanding and remembering what a volume is, a lot of this stuff won't make sense. So in this section, quick review on volumes and why we need one with Postgres. All right. Now I just took the diagram we were looking at a second ago, like this big one right here, in particular the deployment and Postgres pod piece, and I blew it up to be its own kind of diagram right here, as you see. So we still have the deployment, which creates a pod, and inside that pod, we have a single Postgres container. And inside that container is a file system totally isolated to just be accessible by the container itself. Now I want you to recall that Postgres is a database, and the Postgres database, very similar to many other types of databases, though not relevant for Redis because that is specifically an in-memory data store, Postgres takes in some amount of data and writes it to a file system. So we can imagine that a request to write some data or essentially save some data with Postgres comes into the container. Postgres is going to process it and then eventually say, okay, I want to store this information on a file system or a hard drive of sorts. So inside that container, we can imagine that there is that file system and some amount of data is being stored on it. Now here's the thing to keep in mind about any file system that is created or maintained inside of a container. If we ever had a situation where if any reason you can possibly imagine, this Postgres container, or the pod kind of wrapping it and managing it, crashes, then everything over here gets 100% lost, including the file system that exists inside of the Postgres container. So if we just use our copy of Postgres as it stands right now, like this single deployment with this pod inside of it and no associated bells or whistles or volumes and stuff associated with it, if we just write data to Postgres and then that pod or that container eventually crashes, that entire pod is going to be deleted by the deployment. And a brand new pod is going to be created in its place. And this new pod is going to have absolutely no carryover of data. So none of the data on the file system of the original container gets brought over to this new container or the pod that wraps it. So essentially, the instant that the deployment starts up a new pod, we lose all of the data sitting inside of our database. And as you might guess, that is 100% not something we want to ever deal with. We never want to experience any type of data loss with any database, such as Postgres. So that's the issue. If we just let Postgres save all of its data inside the file system maintained by the container, we're going to lose it as soon as this pod crashes or the container crashes. And we have to absolutely assume that that might happen at some point in time. So how are we going to solve this? Well, recall that is where volumes come in. Now, when we had previously used volumes, it was all in the context of kind of being allowed to make changes to our source code files and have them show up inside the container. But we can also make use of volumes to have a consistent file system that can be accessed by a database such as Postgres. So we can now imagine that with a volume in place that is running on a host machine, if we have a request to write data that comes into the container, Postgres is going to think that it's writing it to a file system that exists inside the container, but in reality, it's going to be a volume that actually exists outside on the host machine. The result of this is that if our original pod or the Postgres container inside of it crashes for whatever reason whatsoever, the deployment is going to delete that thing and then create a brand new pod with a brand new copy of Postgres inside of it. But we're going to make sure that this new copy of Postgres that gets created gets access to the exact same volume. And so we'll have access to all of the data that had been written by the previous copy of Postgres that already existed. So that's the idea behind a volume, and that's how we're going to allow ourselves to save some amount of data with a database, but not have to worry about all the data inside there being deleted anytime that the container has to be restarted or crashes or whatever reason, whatever might happen. Now, one quick thing that I want to mention here, you'll notice that inside of our Postgres deployment, you'll recall we put down replicas of 1 right here. Now, I want you to recall that I told you, yeah, we can set up Postgres to have like some amount of replication or clustering that's going to improve the availability and performance of our database. Just to make sure it's really clear, if we just like bump that up to replicas like 2 right there, we would end up with a situation like this, where we have 2 pods that might be accessing the same volume. Having 2 different databases access the same file system without them being aware of each other and have them very distinctly cooperating with each other is a recipe for disaster. So at no point in time are you ever going to want to just arbitrarily dial up replicas to 2 like so and attempt to have 2 copies of Postgres accessing the same volume. Now that's not just isolated to the world of Postgres. Many other databases you're going to find the same problem. So for whatever reason you want to scale up your copy of Postgres and make it more available by having more copies of it running or whatever it might be, you have to go through some additional configuration steps besides just incrementing that replicas number right there. So again, I just want to make sure that was really, really, really clear. Okay, so now that we recall why we make use of volumes and why a volume is so important to use with a database, let's continue in the next section where we're going to start to talk about exactly what a persistent volume claim is and how it's going to assist us in setting up a volume for our Postgres pod. So quick break and I'll see you in just a minute.